Hi, grades off. Welcome to trigonometry session. This is our part 4 where we're going to be focusing on solving trig ratios by graphing. And this is a question that you'll find in question 5 on your paper 2, right? When you're writing your paper 2, you get this question mostly on question 5 or question 6 where you have to express certain trig ratios in terms of certain unknowns, and we covered this a bit in the revision series, but in this session really I just want us to closely look at it, also combining the knowledge of compound angle identities and also double angle identities. Okay, for our content outline, we're still using Mind Action Series, Mathematics Textbook, and Workbook. Okay, let's now focus on examples involving diagrams and Pythagoras. Okay, so I told you that this question, you mostly find it in question 5 on your paper 2 or question 6. It's always there, right? So it's always there. But now I want us to look at it with this combined knowledge of double angle identities and also compound angle identities. So this is our example 1, and you're given that if tan theta is equals to 3/4, right, and theta is the element of 180 degrees to 360 degrees, they say calculate without the use of a calculator and with the aid of a diagram the value of a. They want what? They want sine 2 theta, right? So before calculating, what you have to do always is you have to sketch a Cartesian plane, and you definitely have to sketch a triangle that will assist you in getting the values of these other trig ratios, right? So our first step really is to go and sketch a Cartesian plane, and we're gonna sketch a triangle, right? So before sketching a triangle, you must know where your triangle is going to be positioned. Is it on the first quadrant, second quadrant, third quadrant, or fourth quadrant? And this is aided by the given information. These two given information will help you to know in which quadrant is your triangle going to be, right? So you are given that tan theta is equals to 3/4. So we can see that our tan here is what? It is positive. Can you see? It is what? It is positive. So because our tan is positive, we must know on the Cartesian plane where our tan is positive, and we know it's positive on the first quadrant because we have all of them, and also on the third quadrant because we have tan there, right? So it's on the first quadrant and on the third quadrant, right? So this other given information will now give us really the quadrant that we're gonna sketch our triangle, right? So they're saying theta is the element of 180 degrees to 360 degrees, and we know that here is 180, this is 270, and this is 360, also 0 there, and also 90 here, right? So because theta is the element of 180 to 360, it's this quadrant 180 and 360, that quadrant, right? But we need to draw where our tan is what? Is positive, so we definitely know that it's gonna be on the third quadrant here, because it's where our tan is positive and it's where our angle is located. Okay, so just going to draw a triangle there, right angle triangle, put your theta there. Then you look, what is our tan theta according to the trig ratios? Tan theta is equals to what? Is equals to opposite over what? Over adjacent. Can you see? It's opposite over adjacent. So what is your opposite? Your opposite is this one, which is what? Which is 3. But because it's located on the negative side of y, then it's gonna be -3. Can you see? So you must be very careful there, not just to write 3, but also to look where your y is located. It's located where our y-axis are negative, right? What is our adjacent? Our adjacent is 4 our adjacent is 4, but because it's located on the negative x, so it's gonna be what? Minus 4. So still it will remain 3 over 4. If you say tan theta opposite over adjacent, it will be minus 3 over minus 4, which still gives you what? 3 over 4. Can you see? Okay, now after sketching, we can now go and determine our hypotenuse. Can you see? We can determine our hypotenuse. How do we determine the hypotenuse? By using the theorem of what? Of Pythagoras, to say r squared is equals to x squared plus y squared. So our x squared is minus 4 squared plus our r squared is, y squared is minus 3 squared, right? So r squared is gonna be 16 plus 9. This is 25, right? This is gonna be 25. Then I apply the square root to root of 25. Then it's gonna give me what? It's gonna give me 5. So r is equals to 5 there. So my r is 5, right? Okay, now you are sorted. You have your r, you have all sides of a right angle triangle. You can now go and determine the values of those other trig ratios, right? Okay, they want sine 2 theta, sine 2 theta. So if you take a look at the angle that you are given there, it's not on the diagram, right? So how do we do this? We first need to express this in a way that it will have angles that are in the diagram, so that we can get the answer of that, right? So we know that sine 2 theta is a rule, right? Double angle of sine, it will change into what? Into 2. We multiply by 2, then we divide the angle by 2. So we multiply by 2 sine cos, and we divide the angle by 2, then we'll be left with theta, theta. 2 sine theta cos theta. That's the rule, right? And we covered this when we did double angle identities. I think it was in part 3 of our session. Okay, so now they are expressed in terms of theta. Now we can go on the diagram and determine their answers, right? 2. What is sine theta? Sine theta is equals to what? Opposite. Opposite over hypotenuse. Can you see? So it's going to be minus 3 over 5, because our opposite is minus 3, hypotenuse is 5, right? What is our cos theta? Our cos theta is adjacent over what? Over hypotenuse. So it should be minus 4 over what? Over 5. Can you see? So now we can determine the answer. 2 times minus 3, minus 6. Minus 6 times minus 4 is what? Minus 6 times minus 4 is positive 24. 24, then 5 times 5, it's gonna be what? 25. So this will be the answer for our sine 2 theta. Can you see? Okay, let's go to number B. Okay, for number B, they want the value of cos 2 theta, right? So with cos 2 theta, we know that 2 theta is not on the diagram. Can you see? On your diagram, you don't have 2 theta. So it means that we first need to express this cos 2 theta into trig expressions that have theta, right? So we know that cos 2 theta is double angle of cos, and we know the rule. It will be what? Cos squared theta minus what? Sine squared what? Theta, right? Or you can write it to say 2 cos squared theta minus 1, or someone can choose to say 1 minus 2 sine squared theta, because cos 2 theta can be changed into three identities, right? Okay, so now cos squared theta, so we're gonna get the answer for cos theta. I think we already did. It's adjacent of hypotenuse. It's gonna be minus 4 over 5, minus 4 over 5, but this is squared, right? Minus into sine squared theta, opposite over hypotenuse, and it was minus 3 over what? Over 5 squared, right? Minus 4 squared is gonna be 16. 5 squared is gonna be 25. So this will be 16 over 25. Minus 3 squared is 9. 5 squared is gonna be what? 25, right? So if we take the lowest common factor, 25, we'll be left with 16 minus what? Minus 9, right? So 16 minus 9 is what? It's 7 divided by 25. So that will be the final answer for our cos 2 theta. Can you see? Okay, let's go to C. Okay, C, I'll just introduce the compound angle of tan because I didn't cover it during when I was doing the session for compound angle. But in this session, really, you'll also know how tan can be changed to say how it can be written as a compound angle identity, right? So now you have tan 2 theta. So with this one, obviously, because you don't have 2 theta there, so definitely you need to change it in a way that it will have theta. But I know because I didn't teach you this, it might be a bit difficult for you to change it. But here's it. So the compound angle for tan, it says tan, because it's 2 theta is the same as theta plus theta, then it will be equals to tan theta plus tan theta divided by 1 minus tan theta times tan theta. So that's the compound angle of tan, how you can change it, right? So it's the same as tan theta plus tan theta over 1 minus tan theta times tan theta. So if it's positive here, what you do on the denominator here, you just change the sign to be minus. Okay, so now you have tan 2 theta. So it's just gonna be what? It's just gonna be tan theta plus what? Tan theta divided by 1 minus tan theta times tan theta. So that's the compound angle of tan, right? So know it. Okay, what is our tan theta? We were given is 3 over 4, right? So it's 3 over 4 plus what? Plus 3 over 4 divided by 1 minus what is our tan theta? 3 over 4 times what? Times 3 over 4, right? So 3 over 4 plus 3 over 4, it's gonna give us, if we take lowest common denominator 4, it will be 3 plus 3 here, then under there it's 1 minus 3 times 3 is 9 over 4 times 4 is 16. Okay, let me try to simplify this. 6 over 4 divided by, here if I take a lowest common denominator of 16, I'll be left with 16 minus 9 there. Then let's see if I can simplify. Let me just delete this triangle because of space. Okay, then it's 6 over 4 divided by what? By 16 minus 9 is 7 over 16. Then it will be 6 over 4. If I change it to be multiplied, it will be multiplied by 16 over what? Over 7. Then 6 times 16, it's going to give us what? 96 divided by 4 times 7, it's what? It's 28. So that will be the final answer, 96 over 28. So in this one for compound angle of tan, really I want you to learn this, right? Because this is a rule. Although I didn't cover it in that session, likely we have it in this example. So you know that if I have tan 2 theta is the same as what? Is the same as tan theta plus theta, which can be changed into this. So that is the compound angle formula for tan. It will be tan theta plus tan theta over 1 minus, right? Why minus? Because the sign is positive, under you change the sign to be minus tan theta times tan theta. For example, if I had tan A minus B, it will be what? Tan A minus, right? Minus tan B over 1. Then I change the sign on the denominator because it was negative, it will be plus tan A times tan B. So that's the double angle, that's the compound angle formula for tan, and please really also know it. Okay, let's now look at example number 2, and we are still doing solving trig ratios, expressing them in terms of certain unknowns. by actually graphing. I mean sketching firstly the Cartesian plane, and you draw your right angle triangle, determine its values, and then you'll be able to express those trig ratios. Okay, so I already told you that this kind of question you'll obviously find it in question 5. Go and look at your paper 2 final examination, trial examination, tuning examination. Question 5, really, you'll see that this question is almost always there, right? So it's always there. You'll just find express the following in terms of what, where you just need to first draw your Cartesian plane and your triangle, and also use Pythagoras to solve some of the unknown sides of your triangle. Okay, so let us look at our example 2. You are given that if sine alpha is equals to 3/5, and you are given that alpha is the element of 90 degrees to 270 degrees, right? And you are also given cos beta is equals to 12/13, where beta is the element of 180 degrees to 360 degrees. Can you see now? You are given two trigonometric equations here, and there are also the restriction of their angles to say they are between this one and this one. So it means that in this case we have to sketch two triangles, right? Because we have two different angles there. Okay, so we know this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees and 360 degrees. Let's start with that one. Sine alpha is equals to 3/5. What can you see? We can see that our sine alpha is what? Is positive. And where is sine alpha positive? On the second quadrant and also on the first quadrant, right? But they are saying the angle is between 90 and 270. Let's go to 90 and 270 and check where sine is positive. It's which quadrant? It's the second quadrant. It's on that second quadrant. That's where we're gonna sketch our triangle. So this is really how you determine how you're gonna sketch that triangle. So it's alpha there, and we know that sine alpha, it says what? Opposite over what? Over hypotenuse. Opposite over hypotenuse. So our opposite is 3. So it's on the positive y-axis. So it will remain 3, right? Because it's on the positive y-axis. What is our hypotenuse? Our hypotenuse is 5, and our hypotenuse is always positive. So it will be 5. So here we really need to go and determine x, right? Okay, we'll do it. Let's just draw the second triangle. You are given cos beta is equals to 12/13, and your cos here is what? Is positive. It's positive. And where is cos positive? That's the question you ask yourself in order to draw these triangles. Where is cos positive? It's positive on the first quadrant and also on the fourth quadrant, right? But here they want you to draw on an angle where it's between 180 and what? And 360. 180 and 360. So definitely we're gonna sketch there where our cos is positive. Can you see? So our triangle is going to be here. Then let's see what is our cos. Our cos is defined as adjacent over hypotenuse. Adjacent over hypotenuse. Our adjacent there is 12. Then our hypotenuse, which is facing 90 degrees, is what? Is 13. So in this case we need to determine y. Can you see? So after sketching those triangles like that, you can go and determine the unknown sides using theorem of what? Of Pythagoras. Let's go on this first triangle. So on this one, we know theorem of Pythagoras says hypotenuse squared, it will be 5 squared plus the sum of the other two sides squared. It will be like this, 3 squared plus x squared, and it's Pythagoras. Then it will be 25 minus 9 is equals to what? X squared. So this will be 16 is equals to what? X squared. If I apply the square root, I have to say plus or minus 16, also here square root, right? X will be equals to plus or minus what? 4. Now we need to know, is our x on the positive side or on the negative side? Check your x. It's on the negative values of x, right? It means here our x will be negative 4. Can you see? Okay, let's go and determine y on that other triangle there. Okay, so we're gonna use theorem of Pythagoras to say hypotenuse squared, it will be 13 squared is equals to the sum of the other two sides squared to be 12 squared plus y squared, right? 13 squared 169, 12 squared 144. I take it to the other side to be minus 144 is equals to what? Is equals to y squared, right? So 169 minus 144 giving me 25 is equals to y squared. To get my y, plus or minus root of 25 is equals to y in the square root. So y, it will be plus or minus what? Plus or minus 5. Let's go and check. Is our y on the positive side or on the negative side of y? It's on the negative side of y. It means our y must be negative 5 there. So y is going to be negative 5. So now we can go and calculate without the use of a calculator and with the aid of this diagram the values of these trig ratios. Okay, the first one, it says sine alpha minus beta. We need to determine the value of sine alpha minus beta. Okay, so we know that this one is compound angle of sine, right? We can expand it to say sine alpha multiplied by cos beta. For sine, we keep the sign. So if it's negative, it will remain negative. Then say cos alpha sine beta. Can you see? Then after expanding it like that, we know that we can go on the triangle and determine the values of those trig ratios, right? So let's go on the diagram. Let's go and look for sine alpha. Sine alpha, we already given it on the given information. It's 3 over 5. Also on the diagram, to be opposite of hypotenuse, 3 over 5, right? Gonna write 3 over 5. This is cos beta. Cos beta, remember here we have beta, right? Sorry for not writing that. We have beta there. So cos beta, it will be adjacent over what? Over hypotenuse. Adjacent, which is 12, over our hypotenuse, which is 13, minus cos alpha. Cos alpha, let's go to this triangle for alpha. Cos alpha to be adjacent over hypotenuse, so it will be minus 4 over 5. Can you see? Then lastly, we have sine beta. Sine beta, it will be opposite over what? Over hypotenuse, so it will be minus 5 over 13. Can you see? Then we can just go and determine the answers for that. 3 times 12 is going to give us what? 36, right? 5 times 13 is going to give us what? 65, minus into minus 4 times minus 5 is going to give us positive 20, right? Then 5 times 13 is what? Is 65. 65. Then if I just subtract the 2, take the lowest common denominator, 65, be left with 36 minus 20. And 36 minus 20 is what? Is 16. So it will be 16 over 65. And this will be the answer of my what? Sine alpha minus beta. So you can take a look and you can see that now in this question, which will be definitely a question 5 in your paper 2, they really want you to use the combined knowledge of what? Of compound angle identities, reduction formulas. You'll see it as I do example 3. They also need you to combine knowledge of double angle identities, and also you need to be able to know something that we covered on our revision. I'll just drop the link on the description below this video. And really all this combined knowledge is just needed to apply in one question, and it's very, very effective if you really go and master all our sessions from our session 1, which was our part 1 revision, up until this session. Okay, so let's just go and do number 2. Okay, for number 2, you are given cos alpha plus beta. They are saying determine its value, right? Without the use of a calculator, definitely, but by the use of the diagram. So cos alpha plus beta, we know that we can express this as what? As cos alpha cos beta. Remember, compound angle for cos, it's cos and what? And sine. But for cos, we change the sign. So if it's plus, it's going to be minus. Then sine alpha sine what? Sine beta. Then you just go on your triangle, you get the value of cos alpha, cos beta, sine alpha, sine beta. You substitute and get the answer. Okay, so just go and do that. For the sake of time, let's just move quickly to number 3. Okay, number 3, it's quite a challenging question because you're given like 3 angles. Can you see? It's 90 degrees, minus alpha, and plus beta, right? So one can solve it in this way to say, we can write cos, and we say 90 degrees minus, and then we just write it as 2 angles, right? Can just write it as 2 angles to say 90 degrees minus, then put those one as 1 angle to say to be, if I take minus as a common factor, to be theta minus beta, right? Then you can just go and use what? You can use a compound angle for cos, that says cos, so it will be cos 90 degrees, then cos what? Cos alpha minus beta, then also because it was minus there, it will be plus, then it will be what? Sine 90 degrees times sine alpha minus beta. But it's going to be quite complex, can you see? Because you also need to express this one, you also need to express this one. Okay, let me just show you another simple method. Okay, the simple method here will be to change this, right, using reduction formulas. Do you still remember reduction formulas about cofunction, co-ratios, and all that, way you can simplify and reduce this trig ratio? So how can I do this? We have 90 degrees, and we know 90 degrees can change cos into sine, but we need to write it in a proper way before we change it. So it's 90 degrees minus into what? Alpha minus beta. So I'm just writing it in a way that you'll be able to see that this is 1 angle, right? After that, let's go 90 degrees minus an angle. 90 degrees minus an angle is found on the first quadrant where all are positive, so our answer need to be positive. So 90 degrees is gonna change cos into what? Into sine, right? Remember, cos changes into sine, then to be sine alpha minus beta. Then you can just expand that one. We know it's compound angle for sine, it will be sine cos, so it's sine alpha times cos beta minus, because for sine we keep the sine, then we say cos alpha times sine beta. You can just go on your triangle, look for sine alpha, cos beta, cos alpha, sine beta, and you just express it and get the value of that. Okay, so it's simple as that. Okay, let's just look at our last example and see how this goes. Okay, here's your example 3, and this is some sort of like different way in which they can give you in your question 5 or question 6 on your maths paper 2, right? And although I already covered some of this in part 1 of our session, of our revision session, but I want us really to look at it also given the added knowledge about compound angle identities and also what? And also double angle identities. Okay, so you're given in your A that if cos 25 degrees is equals to K, determine the following in terms of K, right? They say number 1, cos 155, 2, cos 50 degrees, 3, sine 25, 4, sine 50 degrees. Okay, so also in this question, what you have to do firstly is to sketch your Cartesian plane, right? You draw your Cartesian plane, and you are going to look at a quadrant in which you're gonna sketch your triangle. And this one is quite easy because you are given the angle, right? So it's easy to identify the quadrant. We know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and what? And 360 degrees. So 25 degrees is definitely between 0 and 90. It means it's the first quadrant. Our triangle is gonna be on that first quadrant there, right? We put 25 degrees there. Then what is your cos? Cos 25, it's K, but we can say this is K over 1, right? So that we can say this is our adjacent, cos says adjacent over what? over hypotenuse. So our hypotenuse will be 1 there. So cos 25 to be adjacent, which is k over what? Over hypotenuse, which is 1, because k over 1, it's how we can write that thing there. Okay, so now we need to solve for what? For our y there, using what? Theorem of Pythagoras. So let's go and use theorem of Pythagoras. So it says hypotenuse squared is equals to the sum of the other two sides squared, k squared plus y squared. We need to solve for y. So it will be 1 minus k squared is equals to y squared. Then I'll apply the square root plus or minus 1 minus k squared is y, right? Root of y squared. So this will be plus or minus root of 1 minus k squared is equals to y. Can you see? So our y is plus or minus. So we check our y. Is it on the side for y where it's positive or negative? This side is positive y, right? So our answer there is 1 minus k squared, which is the positive one. Okay, so we can now go and express the other trig ratios in terms of k. Okay, the first one that you are given is cos 155 degrees. So before expressing them, you must make sure that all the sides of your diagram of your triangle there are filled, and also all the angles are also filled. So here it's 25 degrees. So definitely there we're gonna calculate sum of angle of a triangle is 180. So 180 minus 25 minus 90, it's gonna give me 65, right? So there it's what is 65 degrees. Then perfect, we can go and calculate and express this in terms of k. Cos 155 degrees. So in most of this one, if they give you an angle, if you check 155 degrees, it's not on the diagram. Can you see? We don't have 155 degrees. So you need to find ways in which you will reduce this angle. And also, this calls for knowledge that you learned in our session 1, which was a revision for reduction formulas, how you can reduce trig ratios into simpler trigonometric ratios, right? Okay. Cos 155. I already taught you how you can reduce, right, in that session. But let me just remind you again. You are going to check my 155 degrees is found on which quadrant, right? So definitely it's between 90 and what? And 180. It's found on the second quadrant. And how is my second quadrant defined? It's 180 degrees minus what? Theta. So it means that if you need to reduce cos 155, you're going to say 180 degrees minus a certain angle that will give you 155. So you say 180 minus 155, right? To get that angle. So it is 25 degrees. So 180 minus 25, it's still what? It's still 155. Then in that way, we can reduce it to say cos 180 minus 25. We know that on 180 minus an angle, we have what? We only have sine. It means cos will be negative there. If we reduce it to be negative, cos what? 25 degrees. Can you see? Then after that, you got an angle that is on the triangle. You can express it in terms of k. Cos is adjacent over hypotenuse, which was negative k. So it will be negative k over 1, which is what? Negative k. Can you see? That will be the answer there. Okay, let's go to number 2. Cos 50 degrees. Can you see? You are given cos 50 degrees. This one is an interesting one because it also calls for knowledge of double angle that we just covered in the previous session, in section 3, part 3. Okay, cos 50 degrees. Take a look at your diagram there. Is there 50 degrees there on your triangle? No, we don't have 50 degrees on our triangle, right? So now you need to find ways in which you can express this in terms of angles that are in the diagram so that you can express it in terms of k, right? So that you'll be able to express in terms of k. So we know that we can rewrite cos 50 degrees in terms of an angle that is on the diagram, which is 25. How can we do that? It's the same as cos 2 times 25 degrees, right? It's the same as cos 2 times 25 degrees. So we have expressed in terms of an angle there. Just simplify it a bit so that you'll be able to solve. Can you see? So what we're gonna do, we know there's a rule. This is double angle for cos. Remember double angles that we covered in our part 3. So this is double angle for cos. You can change it into that one for cos. So I can change it to be 2 cos squared 25 degrees minus 1 minus y. Why am I choosing cos? Because I know that I have cos that is already being expressed in terms of k. So it will be simpler to express that one in terms of k. Or someone might choose to use the long method to say that one is the same as, some people can choose to say cos squared 25 degrees minus sine squared 25 degrees. It's not wrong, because 25 degrees there, you can go and get those one in terms of k and substitute, but it will be quite a long method. So it's better to choose something that will just simplify your work there, right? So we write it like that. Then after that, it will be what? 2. What is our cos 25 on the diagram? Is adjacent over hypotenuse. So it's k over 1, which is k, right? So it's k, but this is squared minus 1. So this will be 2k squared minus 1. Can you see? It's 2k squared minus 1. Okay, let's go to number 3 now. Okay, number 3, you are given sine 25 degrees. And if you check, 25 degrees is on your diagram there, right? It's on your triangle, you have 25 degrees. So that one is going to be very easy to express. What is sine? You just need to know how sine is defined. Sine is defined as what? As opposite. Opposite over hypotenuse. Opposite over hypotenuse. So we're going to say opposite, which is our root of 1 minus k squared, over our hypotenuse. Our hypotenuse is what? Is 1. So when I simplify that, it will remain 1 minus root of 1 minus k squared as my sine 25. Can you see? That one was a bit simpler. Let's go to the last one, number 4. Okay, number 4. You are given sine 50 degrees. Sine 50 degrees. We don't have 50 degrees on the diagram, but we can write it using the knowledge of compound angle. I mean, double angle, or someone can choose compound angle, but I'll just choose the simpler one, which is double angle in this case, right? So I can write sine 50 into 2 times, sine 2 into what? Sine 2 into 25 degrees, because I know 2 times 25 is 50, right? So this is a rule. It's double angle of sine. How is it changed? We multiply by 2, then we divide the angle by 2. So it will be like that. So 2 sine 25 degrees times cos 25 degrees, right? So we already calculate sine 25 degrees. Do you still remember? It was what? It was root of 1 minus k squared, or you can just go back on the diagram and look for it. Cos 25 degrees is also adjacent over hypotenuse, which is k over 1, which is what? Which is k. So if I simplify this, it will be 2 root of 1 minus k squared multiplied by k. So these 2 can just multiply by k this side, and I can write it like that. 2k root of 1 minus k squared. Okay, so for number B, I'll just give you this as your fun activity exercise. I want you to go and write this one, and just drop your answers on the chats or send me on WhatsApp. Those who have my WhatsApp number, if you don't have them, you can just drop a comment. Can I have your WhatsApp number? Then you can send me your answers for this fun activity exercise. So this will just be your fun activity exercise, and go and test your knowledge on the understanding of this session. Okay.